razie gdyby był problem z tym, wtedy po prostu
Ja szybko idę jeszcze do łazienki.
A, bo jeszcze muszę zdać stanąć. A, dobra. Nie będę zasłaniał chyba, nie? Bo będzie git. A właśnie, chciałem jeden test run, żeby się załadowało obrazki.
Raz. Dwa, trzy. Działa? Działa?
Okay, hello everybody. This is room 2.41. And we have Gracian with us. He will tell us about engineering Fortran to Python bindings in C++ with nanobind JSON and CI build wheel. So let's have a huge round of applause. And this will be a 20-minute talk, and I think there will be maybe time for some questions afterwards, so please keep them. And if you're watching the live stream, welcome, and you can ask your questions on Discord. And I will pass the mic to Gracian.
Thank you. So, without further ado, we can start now. So, quick note on myself. I am a third-year applied computer science student here at AGH, but a different faculty. I am a president of a computer science scientific lab that brings together students from our faculty. I was a summer intern at Polshire Institute last year. This year I am a summer student at CERN. I have also worked as a C++ developer. I really like the Mo animal. I am interested in high-performance computing, GPUs, and all the other fun stuff. And you can also find me on GitHub as Grieger5. So now a little background. This talk will kind of be a case study on a package called PyPartMC, which is an interface to PartMC, which in turn is written in Fortran. And I am a contributor to the PyPartMC piece. So now about PartMC itself. It is a particle result Monte Carlo code for atmospheric simulations. It has been developed on University of Illinois Urbana-Champaign. It is in development for 20 years now. It has more than 4,000 citations in research papers. And it is written in object-oriented way, but before Fortran actually supported that. So it's kind of made as you would do it in C, for example, which doesn't have the inherent support for objects, but you can still code in the object-oriented way. And now what is PyPartMC? As I said, it is a Python interface to that. It has been developed at IUC and AGH, University of Krakow. And what we wanted to achieve was a uniform interface across multiple languages. Also to use the unmodified code of PartMC so that with future releases we can easily switch to them. To not use any additional files which we'll later see had to be used with PartMC. For it to be usable as just a Python script or just a notebook also in the Google Colab Cloud. For it to be pip installable with a single command and no further dependencies needed. And also for it to be available on Linux, macOS, Windows, and also Linux ARM devices. And now a comparison of the uniform API across multiple languages. This is code in Python from the PyPartMC README. And it's basically a small Hello World example. Here's a comparison with the same code in Julia, which you can see is almost the same, basically line by line. You can also use it in MATLAB, and again, the API is basically the same. And you can even use it in C++, and it is probably the most verbose of those, but it still basically functions as the same code. Here is an example of how you could use PartMC itself in Fortran. And as you can see here, instead of defining the parameters in dictionaries or arrays, you actually read from some files. And this is because PartMC functions less as a library and more as an executable binary, which you kind of control with the spec files, with the specification files. And this is why PyPartMC was also designed to avoid those and to keep everything in the code. And here is like a high-level overview of the project architecture. So basically, we have code both in Fortran, in C, in C++, and in Python. And it is also callable from Julia and MATLAB through their respective Python bridges. And another comparison between just the two packages. They have quite a few lines of code. PyPartMC has 1/3 of what PartMC has. They also have more than 200 and 100 files. They have a pretty high reported code coverage for both of the libraries. And PartMC, as mentioned, is primarily written in Fortran, and PyPartMC is written across Fortran, C++, and Python. And inside those C++ parts, there are C parts. We will go through that too. So now let's see how we go from the core Fortran library to C. What we use is the Fortran SoC bindings, which are basically a unified interface across different compilers, which was, I think, introduced in Fortran 2003. We can just use this package. And then when we define a subroutine or a function, we add bind C, and there are also some other arguments that you can use. And what it does is it basically prevents the Fortran compiler from name mangling. So this symbol can be linked with a compiled C program. And here we just call the PartMC function directly because this is actually code from PyPartMC repository where we wrap over the PartMC functionality. And then in our C or C++ file, we can just define without we can declare without the definition the function name, and then the linker will link them. To go from C to C++, it is actually very simple. We can just use the extern keyword with C. And what it does is it also prevents the C++ compiler from name mangling. So it is also, the symbol is also just as we described here. So if it matches the name of the one in Fortran, then you can just use it. It will be linked, no problem. To go from C++ to Python, we previously used PyBind 11, but I did the porting to NanoBind, which is created by the same person as basically a successor. It was created by an associate professor at EPFL. It exposes C++ to Python and vice versa. Basically well, not every, but the defined C++ types can be easily sent send in quotation to Python and back. And it is just a convenient wrapper over the typical C API for Python, but it has really minimal boilerplate if you would compare them to. Here is also an example from PyPyRDMC. Basically, here we see an example of how to just put a standalone function to be callable from a Python module, and also how to bring a whole class with the properties and methods to it. As you can see, for example, for the functions, we do not need to pass any types of the parameters. It is all done with the template metaprogramming on the nanobind part. And we just call them like this in Python. You can also define custom typecasters to nanobind if, for example, your third-party libraries or something is not supported. For example, we were using optional as a third-party library. And here it was very simple because nanobind already had a caster for optional, so we just used that for implementation. But for example, they did not support std-val array, which was used in many parts of the library. And this is only a part of the caster. As you can see, it is a bit low level. But thanks to that, it helped us to not rewrite a big chunk of library that was using val array. Now all lists and tuples and even numpy arrays will be turned into a val array when called, when used as an argument to our function. Now back to the diagram. You may also wonder about the second path that goes from Fortran to C++. And you can see that in the name it is the spec files, which basically look a little bit like this. And you can see that this is the same thing that we have in the dictionaries in Python and the other languages, but as a separate file that we would then pass to the binary. And for that, we use JSONs. And why? Well, to have the flexibility of supporting multiple mode types for a particular object. Because as you can see, everything here is an aerodist object, but there are different, okay, on this example, they're all the same, but we'll see in a minute. It also helped to provide the uniform interface for the different languages. As I said, thanks to that, we don't need to use other files. And it is also invisible to the user. They don't know that it will be passed as a JSON. You just see it as a dictionaries or arrays. It is just an implementation detail. And here is the example of different mode types having different arguments. And to do it, let's say, without us passing the dictionary, but using the keyword arguments, it would be a bit more work to have it, let's say, in a Pythonic way. And for that, we also need nanobind JSON, because nanobind itself does not support JSON operability. And we found a package from 2 years ago, but unfortunately, when we found it, it was broken and not working and said to be unmaintained. So we adopted it, and I became its maintainer. And now it's even mentioned in the official nanobind documentation. And I also managed to add some other stuff that was not available even in the PyBind 11 equivalent. Now to take a look at the, let's say, whole code path across all languages, how do we actually provide the code coverage? It's pretty simple. In our CI on GitHub Actions, we just pass necessary flags to the C, C++, and Fortran compilers, and then we use lcov to make it a digestible format for the codecov on GitHub. But we also had to take care of the memory management and the garbage collection of Fortran objects. For that, we define a constructor and destructor function for every object type, which we then, of course, also expose to the C++ layer. And in the C++ layer, we have a thin wrapper over basically every object, over every pointer to a Fortran object, where we also hold the pointer to the constructor and destructor. And, well, when the constructor is called, we call the constructor. When the destructor is called, we call the destructor, and we clean up the objects. And here is the example we just created in the object constructor. And this is the overview of how it works. Basically, whenever the Python garbage collector will delete the object or it goes out of scope, the C++ wrapper will call the saved pointer, which will then call dialog in the Fortran core library. And to package it all up, we wanted it to be installable as a single pip package with no other dependencies. Because for comparison, to use PartMC, you needed to first install numerous dependencies. This is the screenshot from the PyPartMC repository of all the dependencies that are needed. You had to perform the multi-language compilation and also have knowledge of Bash, Fortran, and Python to actually run it. But to run PyPartMC, all you need is to pip install it, and then it's done and you can use it. Or you can also use it in an example notebook, also on Google Colab. So it's very easy to share and develop together. But the problems were that first, there isn't one uniformly used package manager for C++ or Fortran, so we couldn't depend on that will support all the packages that we need. So we linked everything statically, and every dependency is shared within the library. And whenever necessary, we patch the submodules because all of the dependencies are Git submodules in our repository. So here is a small example of some Python magic to make sundials work. And also here is some CMake magic to make one of the libraries work on Windows, because of course it wouldn't work normally. But our biggest trickery that we have used in CMake, maybe a little background of why we even needed that. As I said, we switched from PyBind 11 to NanoBind, and our build backend has also changed from setup tools to scikit build core. And because of that, whenever we do the install PyPartMC, scikit build wanted to install all of the dependencies too, which we first didn't need because we linked them statically, and second, the user probably doesn't want it. So, as I said, we need the install to work for only our package, but not the other ones. And we had to resort to an undocumented CMake feature, which we had found on a mailing list on the CMake website, which, at the time of making this presentation, was already archived and couldn't be found. But thankfully, it was saved on Web Archive, and I got a screenshot from there. And basically, in CMake, if you shadow a name of a function or a macro, then obviously just the name will do something else. But if you do underscore name, it will call the previous implementation. So what we did is at the start of our CMake, we defined an empty macro for the installation. So every time install was called, it would do nothing. But at the end, we used install with the underscore, so it actually installed. And all the other packages that did nothing on that step. But now you may also ask if Git submodules are even maintainable, because, well, you would need to bump the version yourselves, always check it. But, well, actually, it is very easy. For that, you can use dependabot on CI. And what it does is that, for example, weekly, it will check if there are new versions of the submodule available. And if they are, it will not only, well, raise an alert, but also make a pull request with bumping of the version. And for the packaging specifically, we use CI build wheel. It is created and maintained by the Python Packaging Authority. And it allows you to very easily create wheels for different operating systems, different versions, and different architectures. And you can do all of that in CI. And also CI build wheel can automatically run your test suite, so everything is in one place, in one CI run. And here are screenshots of it. We had our package built on Ubuntu, Ubuntu ARM, 3 versions of macOS and Windows. And if you look into the CI logs, you can see that CI build wheel basically goes through every Python version and every system and builds the wheel, tests the wheels, and then you can also uploaded to PyPy also directly from the CI. Here's the piece of code that we used. You can also see a lot of other workarounds. For example, here, changing the name of the temp folder on Windows, because some of the packages were actually never compiled on Windows, and for example, they would get too long of a name, so we had to change that. Or for example, on macOS, we had to reinstall GCC to have Fortran available. With LLVM Lite, I don't remember what exactly was the issue, but we also had to reinstall it with pip and only install the binary. And as you can see, you can also skip whatever versions you want. You can provide the environment variables if they are needed, the command for testing, and basically CI build wheel allows for a lot of flexibility and it's very easy to use. So, to summarize, how to create Fortran to Python bindings. You can create a C or C++ interface with the ISO C bindings, which I think are the standard to do it with modern Fortran. You can then create bindings to Python with either PyBind 11 or NanoBind. You can even add garbage collection for the Fortran object if that is necessary. You can also maintain your Git submodules with the Pendabot if that is necessary. You can compile the library with CMake, and then package it as a Python wheel with CI build wheel in your CI workflow, upload it to PyPy, and you can enjoy your package. Here is a couple of useful links. First to the PyPartMC repository on GitHub, also to the article in SoftwareX about PyPartMC, and to the NanoBind JSON library also on GitHub. And thank you very much.
Okay, thank you again. We have time for like one or two questions. You can raise your hand, I'll pass you the mic.
Thank you very much for the nice presentation. So during your presentation, you mentioned that one of your objectives is to make the package installable just via one very simple command. And you actually statically linked all of the dependencies. So I'm very curious, like the size of the resulting wheel, was it like big? And did that cause any kind of problems for like the consumers of your libraries? Because I would imagine that prior to that, PyPartMC existed, and the wheel sizes must have been like much more smaller than what you got after you statically linked the dependencies. So like, did you encounter any challenges? Was there any complaints by the consumers of your libraries? So that's just what I'm curious to know.
So I don't remember the actual size of the wheel, but from what I remember, it was not very much. There are much heavier Python libraries. If we ever encountered a challenge with the size, not really, but let's say the one caveat that I can mention is that we also upload the tarballs, so basically just the source code to PyPy. So if a wheel for your OS, your Python version is not available, it will download that and just build the package. And then we do not include the dependencies. Because otherwise, then we had the problem that the tarball was too big to upload it to PyPy. Yeah.
Okay, so if you have any more questions, you can probably find Gracian. He'll be around there. So again, please, a huge round of applause for Gracian. Okay, and we will have a like 10 minutes break. Okay, I think we can start. So welcome everybody. Welcome people on live stream. Our next talk will be by Ruslan about USB-C moment for AI and building MCP servers with fast MCP and Python. So let's have a huge round of applause. We'll have a QA session afterwards, so please take note of your questions, and I'll pass the mic to Ruslan.
Hello, EuroSciPy 2026. I want to talk about MCP, Model Context Protocol. We will talk about fast MCP, Python library, and also we will use Google Anti-Gravity to check how we can connect our MCP server to our IDE and use our agent to talk to our MCP server. And my name Ruslan, because I'm Ukrainian, and you can see now largest military transport aircraft in service. In Ukraine, we have even one bigger built Mriya. However, Mriya was destroyed when full-scale war started in Ukraine. So if one day you forget my name, just check biggest military transportation aircraft. And because I'm Ukrainian, I'm prepared for you Ukrainian traditional iconic drinks and snacks. And why snacks? Because during EuroPython 2025, I noticed snack exchange. When people just distribute snacks from different countries and change during EuroPython in Czech Republic. So let's start with snacks first and next continue. And about iconic drinks, we will play the game. When you will see next time word Ukraine or Ukrainian flag, for example, not on this slide, but on the future slides, you just need to raise your hand and quickly shout Ukraine. Ukraine? Yeah, let's try. 1, 2, 3. Yeah, thank you so much. So please follow my slides today. We will start with problem statement. Why do we need to use MCP protocol? Next, we will talk about MCP architecture, like host, server, client, user. Next, we will talk about fast MCP Python library. I will show you how to deploy our MCP server and test our MCP server. And next, we will use Google Anti-Gravity IDE. It's like Cursor or Visual Studio Code to play with our MCP server. And next, we will move to closing slides. For example, I will show learning materials to go deeper with MCP protocol. If you prefer to use your laptops and mobile phones, because we will see a lot of Python code today, now you can use QR code, or you can just type in your device tinyurl.com/EuroSciPy. tinyurl.com/EuroSciPy. Thank you so much. And let's start with problem statement. Many years ago, when I decided to travel, for example, to Germany from Poland, I collected with myself a charger and cable for my iPhone, separately for my Samsung mobile phone, separately for my Sony digital camera, and separately for my HP laptop. But now it's much easier because in Europe Union we have USB-C, and if you use all modern devices, you can just collect with yourself USB-C charger, and that's all. And historically, just 1 year ago, we was on the same state with AI agents and tools, but now we have MCP, Model Context Protocol, and we can simplify our life because we can use our MCP with Gemini models, with ChatGPT, with Claude. There is no strict dependencies to one provider or one model. And MCP historically created by Anthropic, however, it was great news, it donated to Linux Foundation. So now we can say it's like open source. And promise from Anthropic and Linux Foundation to MCP, you can write your code once and use with all AI models and tools like Cursor or Claude or Anti-Gravity, or even with your local LLM models. And in practice, as of now, MCP is industry standard. All main huge companies use MCP and support MCP protocol. Let's talk quickly about architecture. In practice, we need to talk about user, and user it's usually human, like me today during the demo. Next, we have MCP host, and today, for example, we will use Google Anti-Gravity, and inside Google Anti-Gravity, we can execute our multiple agents. And in this case, our agents is our clients, because in practice, we will have client-server architecture, and our client, like agent inside Google Anti-Gravity ID, will talk to our MCP server. And because today we are on EuroSciPy, we will use Python and Python code to write our MCP server. And finally, how we want to talk between our client, like agent, and our MCP server in Python, we will use streamable HTTP protocol for distributed connection, and locally we will just use standard input-output STDO. On this slide, we can see in details, we have this host application yellow square, and inside we have multiple, it can be single or multiple clients, like agents in Google Anti-Gravity ID. And each time when we have new dedicated connection to server, we can talk, then finally we have client and we have server. And during the demo, I will show you how me as user, let me start laser point, just one moment. So me as user, I will use Anti-Gravity as my host, and inside Anti-Gravity, I will use AI agent as client, and I will talk to my MCP server written in Python based on FastMCP library. So my server is FastMCP based Python code. And finally, my MCP server will help me with finance data from Yahoo Finance. And we will use Y-Finance Python library. So in practice, I will use my mobile internet today and hope it will work well for us. And main primitives we have in our MCP protocol, it's resources, prompts, and tools. And let's start with easiest one, with tools. When we want to execute API call, when we want to execute our bash shell commands, execute operations on files, we need to use tools in MCP and FastMCP library. Resources, it's also not so hard when we need to deal with data and we want to provide some data to our model. The best option is to use resources. And no worries, in the moment I will show you examples, and also during the demo and coding session we will better understand the differences. And finally we have prompts. So for example, when we need to code our system prompt or few short examples, the best idea is to use prompts. In practice, it's here is how to ask our model. Here you can see examples we will use today during the demo. We will name our MCP stocks, and we will use data, for example, watch list. It's just a list of tickers, list of names of companies based on NASDAQ, like Apple, Microsoft. And for prompt, we will use analyze stock. And for example, kindly ask, please analyze Microsoft stock or Apple stock. for me using Yahoo Finance and Yahoo Finance Python library. And the tools, for example, we will use get stock price to collect financial data for our model. And now we are going to fast MCP because we understand why we want to use MCP, because we can write our code once and next use in different IDE with different models and even with local models. And to simplify our lives, we will use fast MCP. And the best analogy is fast API library. Please kindly raise your hand if you used fast API library. Thank you so much. And now do the same for fast MCP library. 2, 3 people. Thank you so much. So yeah, so it's fast API on the MCP ecosystem. And good news, it's Pythonic. It's declarative, so we don't need to go details to explain how we want to do something. We just need to be focused on what we want to achieve only. And we can use type hint, so we can tell our model, I want to see result in dictionary format or in string format. And zero boilerplate, it's about declarative language, so we can simplify our life like we did with fast API library. And let's start with some like hello world. We will name this file stock server min.python, like minimum. We need to import our library fastMCP. We will name our MCP server stocks. So based on this name, our model will be able to find our tools, prompts, and resources from our MCP server. And we want to return result as string. And for this hello world, we will just return this text, stocks MCP service is alive. And we will execute with MCP .run our MCP server, just typing Python name of the file. That's all. And in our terminal, we will see something like this, fast MCP, and we can start chatting with our MCP server. Nothing hard. That's why let's move to more advanced example for today. We will use Yahoo Finance to collect finance data, to analyze finance of Apple or Microsoft company. This time we will also import our Yahoo Finance library. We will name our server the same, stocks, and we will create just a list of tickers we are interested in to be able to show you example how to use resources like Apple, Microsoft, Google, NVIDIA, etc. And let's start with easiest part of protocol, it's tools. And first tool we will create, it's get company info, for example, information about Microsoft, Apple. We want to see name, we want to see sector, industry, country, website if available, all basic information about the company from Yahoo Finance. Next tool, second tool, it's get stock price. And this time we will use fast info from Yahoo Finance because it works fast enough to have smoothest interaction with our agent when we're asking stock price for Microsoft or Google, for example. And here on the first and second example, you can see decorator, mcp.tool. That's how you can convert any Python function to our MCP tool. So just adding this one, that's all. And we can tell our model agent type of result we want to see. In this case, we want to see dictionary with ticker, price, currency, and previous close price for stock market. And last one tool, it's get stock history. By default, we want to see for 7 days, but our agent may ask for 5 days or 30 days or 60 days history to analyze a company and provide for us some suggestion as for investor or trader. And quick question for you, what does it mean OHLCV? Raise your hand and answer, and you can see answer on the slides. Yeah, go ahead. Yeah, exactly. And iconic Ukrainian drink, but please remember to make it cold. Put to refrigerator first and only next to drink. Now let's move to resources. So we want to provide model some data. But usually when we just provide context in our text window, for example, sometimes model completely ignore data we provided. Because we want to be deterministic and we want to make reliable application, we can use resources. So in practice for our application stocks, we will create resource watch list. And as you remember, previously we created this list with name of tickers. So to be able to create resource, we will use another decorator, mcp.resource, and just provide name for our resource. That's all. And the same way we can provide API respond data or data from database or data from file, for example. And good news, we can use resource template. So previously we just declared one concrete resource stocks watch list, but now we want to make it dynamic, so we can provide ticker like abbreviation of company like Apple, Microsoft, and collect information about our company like ticker, name, sector, price, and currency. And finally, prompt. So good example we can use for system prompts. This time I want to kindly ask my agent model first collect company information, current price, historical price, and next provide me with some trend, one risk and one opportunity for investor or trader. So I can simplify my life and next time just put please analyze Microsoft stock exchange. That's all. And my agent will follow all these instructions for me and will execute in other tools we can see here, for example, get company info, get stock price. So prompt is also a great idea for workflows. When we want to execute in some sequences multiple tools to collect data, next to summarize, simplify, whatever we want to do. And this time we will use transport switch because by default we can execute in standard input-output locally, but also we can use distributed model and we can just use HTTP, streamable HTTP protocol. So based on our local variable MCP transport, we can deploy our server to serve local agent or to use HTTP, streamable HTTP protocol. So let's check how we can deploy and test our MCP server. And first, the easiest option is to use local standard input-output stdio. So we will just execute fast MCP, dev inspector, and next name of our Python file with our tools, prompts, and resources. And why I want to execute this inspector? Because I want to test my MCP server with MCP inspector. For example, I can see all my tools, all my resources, or my prompts. I can call all my tools. And in practice, we will see in our browser MCP inspector, and we just need to select transport type stdio and select our MCP server. In our case, it's stocks. So we can do the same, but we just need to change our protocol, transfer protocol to HTTP, and next execute our MCP server application Python code with Python and file of the name. And by default, we will see on local host port 8000/MCP. And if we want to test our distributed version of MCP server, we need to execute this command npx and next provide a model context protocol /inspector. And next, inside inspector UI, we need to select streamable HTTP. So this time we will select streamable HTTP, provide our URL address, clicked connect, and we will see all options to test our MCP server, like resources, prompts, tools, and new one, it's tasks. But it's not for today, but if you're interested, I can recommend also to check tasks as durable executions inside MCP protocol. And final option for today, we want to connect to our agent IDE, and my recommendation is to use Google Anti-Gravity because it's free to use, it's open source, it's based on Visual Studio Code. So if you like Visual Studio Code or Cursor, also you will like Anti-Gravity. And inside Anti-Gravity, we just need to select additional options, MCP servers, manage MCP servers, view raw config file, and we just need to provide information about MCP server. So in practice, we want to execute our Python file with our Python. And in my case, I just used virtual environment and provided path to my Python in virtual environment, and also provide path to my MCP server written in Python with fast MCP library. And locally, I just want to use std.io standard input-output protocol, not HTTP. So that's all. Command, argument, and environment variable for our MCP server. Technically, we also need to refresh after this information. And finally, we will see all information about our MCP server. Name of the server, it's stocks. We check with you today get company info, get stock price, get stock history, and get dividends just written by agent. So you can kindly ask your agent to write MCP for you. And next MCP will use, your agent will use your MCP server written by agent. Very interesting idea, and it, yes, of course, works. So in practice, how we can test, we can just go to our anti-gravity and we can put something like give me basic company information about Microsoft, and anti-gravity discover our MCP server, and next call get company info because it's related to our prompt. Or we can put what is the current price of Apple stock and how did it move over the last 5 trading days. And this time we will execute one more tool, get stock history, and also we will summarize whole result. So let's check in practice how it works. Let's copy, for example, this one. Prompt, navigate to our anti-gravity. Here we can find our MCP server. I have already provided configuration for my. We can just put. Ouch. My fault. So I'm just copy prompt from my text document to put to my agent, and all time when my agent executing MCP, I just need to say, yes, I agree. This time you can see dictionary received by model. Just wait a few moments, and we will see all information and suggestion about Apple company based on my prompt template. We are moving to closing slides and Q&A, and we need to collect at least one question because we have one more iconic Ukrainian drinks. So if you want to learn more, I can recommend Model Context Protocol official website. Also, I prepared a workshop around 2 hours. If you want to go deeper with MCP, you will find on my GitHub. If you want to contact me after the conference, you will find these slides. But no worries, I will share slides in a moment again. And because I'm Ukrainian, do you remember about the game? Who was first from this side? Yeah, could you please kindly deliver this one? Thank you so much. That's why I could kindly ask you to consider option to support Ukraine, and most trustable mature foundation is Come Back Alive, because Ukrainian business support organization, foundation, for example, salaries for employees, and you can donate directly to Ukrainian army. Let me just select laser point, just to select army assist, because this one supported by Ukrainian business. And one more time, slides if you want to download. Questions? Please raise your hand, I will deliver a mic to you. A Q&A session. I will appreciate for at least one question. Yes, thank you so much.
All right, a question for you. What do you think comes next as the MCP evolves and as people have been arguing whether file trees and other kind of sort mechanisms are replacing the initial hype? Where do you see things going in the next couple of horizons, and what's exciting you personally?
So for me, MCP it's for reliability, because we cannot rely too much on LLM models. In practice, we can expect different results all time, even for the same prompt. That's why I like idea of MCP. And in MCP, now fast MCP, we can test tasks as part of protocol, and it's even more reliable. So if you're familiar with temporal workflow orchestration manager, so it's the same durable idea, so we can rely even more for more advanced tasks for our LLM models. So I believe in this direction, durable executions like tasks in fast MCP. Do we have time for one more question? Okay. We are ready for next question. Thank you.
So when we are trying to, first of all, thank you for the talk, but when we are trying to connect to multiple MCPs at the same time, what do you think? Like, do you think it would happen of hallucination or something like that for the MCPs?
Absolutely, we can use the same agent with different MCP servers, because when we send our prompt, for example, as human, our host, for example, Google Anti-Gravity, will check different toolset to understand where to address our question. So we can use MCP server for finance, for example, MCP server for logistics. We can enable the same time. And when we will create prompt for logistic-related domain, our client will send request to logistic MCP server and dedicated tools. And in case we will create prompt related to finance, we will do the same, but for finance. So there is no issue to have multiple MCP servers, multiple MCP tools, and multiple agents. And just to work with multiple agents, again, I can recommend Google Anti-Gravity, because now we have Google Anti-Gravity ID, and separately we have just Google Anti-Gravity 2.0 to work simultaneously at the same time in parallel with multiple agents. Yep, I believe you can do the same with Claude. Yeah, but Google Anti-Gravity is a great new product. And thank you so much.
Okay, thank you again. And now we'll have a break.
You want to do an intro? Shall I just start? I can start. I can very slowly start. Yeah, you should be able to hear me. I think the microphone is mostly for people online, but let's go. Okay, so welcome to this talk. What I really want to talk to you about the coming 25 minutes is a software design pattern I found, me and Niels essentially found very useful over the time of data science projects we've done. Alternative title could be what we would propose for a sklearn metadata routing algorithm or API, but I just realized after the previous talk. Today, so we talk the first part about the software design algorithm or a design pattern, and the second part will be about how we validated it. So we had two master's students writing their thesis with us, with ING Bank, where I'm from. And they used it for the experiment, and I will share their learnings as well. Niels was planning to be here, but he couldn't be there due to personal circumstances. And on top of the student research, we'll apply some learnings from ING Bank R&D group. So you might be familiar with when you're working with experiment code bases. We have sklearn representation as well. Very good. Sorry. Experiment code base is that as your project grows, you start with something simple experiment, something comes by. Your logic gets tightly coupled. For example, you make your writing the data dependent on the data type you choose, like network X or the library. So you get, with your next experiment, you will copy the same file, get repetitive tasks, and this complexity easily increases. At least this is a pattern that we've seen a lot. And what helps there, what we found, is that you can modularize these pipelines and simplify the way of doing I/O. We've published this or presented this at PyData last year in Amsterdam. So I won't go into the framework itself, but what I will show is the design principles behind it and our learnings by applying it for experiments. So what does this really mean? So until now it's pretty abstract. So the basic building blocks are pure functions, and what is a pure function? It's a deterministic mapping from x to y, some kind of input argument or multiple that doesn't produce any side effects. And one of the pure functions you could think of is brew-coffee ratio, where you say the ratio of water in milliliters to coffee solely depends on the input. There's no side effects, and then maybe if you have a validation step, you will get an exception. For people from computer science, this is technically not pure, right? Because these exceptions are not returned as a result, but you can easily come around that. So, but this is the basic building block. A programmer, so if we want to build something, we want to write Python. From these, you can build any kind of interesting machine learning package or pipeline. So for example, usually we start with a train test split, then from the training data we get the training features, so X and Y. X we do processing on, then we train, the output of the model is then used similarly on the features from the test set, and together with the labels we evaluate. So this is a super interesting or super useful way of thinking about this. You can extend this any way you want, so you can add visualization at the end, or you can do some extra correlation analysis on the features. So this functioning pattern, this can express most of the pipelines we're interested in. How we refer to this is as global order and local chaos, meaning you have requirements over the high-level design of your pipeline, but locally within the function you can do anything you want. It's just plain Python, as long as you don't do side effects. But of course, we sometimes want to save parts of our pipeline because we don't want to run the pre-processing every time or even the training. So how do we deal with this? I call this quick serialization. Let's see. So one of the ways to think about that is that you can say, okay, all these outputs, so these arguments are inputs to the next, we can name them. So this exercise of naming them, maybe pre-processed training data, trained model, predictions, That's the first step. And then what we did in this framework is we mapped it to an I/O object. And when is something an I/O object, we paired the load and the save function for a certain data type together. For example, you could be a TOML file, saving and loading, or a Python literal, Parquet file, anything like it. For a model, it could be a pickle, or it could be PMML, anything like that. So in this framework, what we do is we assign to each of the names a mapping to one of those. For example, a one-liner of the Polars Parquet would be to sync, or to sync, reading similarly. And this is just a Python file, but what's interesting that you can then do is you can swap these around. So you can say, okay, my Parquet file on local is this, but on cloud I need additional configuration. You can easily swap between mock and real-world data. You can swap hyperparameters. So the core of this design principle, this design pattern, I mean, is that we have computation on a graph of pure functions that we link together through these IOs, where we say, oh yeah, if another function would need the same pre-processed data, we say, okay, just get that, right? This is by no means a unique finding. Many patterns do this, so any compiler will do this, the Spark Catalyst will do this, Polars will do this, because if you have one, then you can do all these optimizations. The NVIDIA, the Qtile that just was presented this morning is also doing this, right? This I/O part, that's something we just do to be able to support various data types, like saving models or saving predictions. This has come from many of the things that we've worked on so I work at ING Bank, and we do a lot of data science for wholesale banking clients, like big loans, airlines, that kind of stuff. And these are data science tasks associated with it, so it could be data engineering, it could be network analysis, data modeling, model training inference, model monitoring. This one is open source, PopMon, synthetic data generation. We first tried with the sklearn pipelines, and so one of the steps that we have there is that we do a reverse of so we pass the data reverse through the fit, after the fit, and that was very problematic to get right, because this was kind of dynamic pipeline, so this is where this model worked well. And nowadays we also see that with LLMs, where they're very lossy, where we use a lot of this agentic AI, which just means chained LLM calls, right? Let's say they are 80% correct. You do 10 steps after each other, 0.8 to the power of 10. We have to rerun steps of them. Takeaway being is that for most of these applications, it was for us helpful to separate the I/O from the computation. And how we look at this is that the development effort at the beginning is a little bit more, but over time we prevent to have to do a lot of refactors of this pipeline code. If you do a new experiment, if you want to, for example, at the end of when a student is working, you want to ask them to add a line to the same plot of which they've lost the data, then with traditional code it's quite hard. What we see here is actually the big ball of mud, so the throwaway code from the 1999 essay. Let's see. And yeah, second point is that I think here are mostly the interesting applications, right, where we in scientific Python will run into, where you have at least some steps of reasoning over what you're building and solving and getting insights. So the advantages of this pattern to me are it makes orchestration very easy, where you can say, okay, I just want to run this part of my pipeline, only those functions. You can run them async because you know how they depend between each other, and you can also do things like caching, which we presented 2 years ago in Stettin. At the same time, it makes pipeline scale with the project, so the more that you do, you linearly increase the work, at least that's what we claim, instead of exponentially. It's quite easy to go to different IOs. So one of the examples in this network analysis is that you start off maybe with network X, then realize your graph becomes too big, want to scale to something that's C++ backed or has some kind of bindings, then this makes this very limited in the amount of code changes you need to do, because you don't need to do much in your function, mostly in this I/O. I will show there's a natural correspondence between project structure, and it also helps debugging and visualization. So the correspondence this is, for example, one of the model monitoring projects that we have. So each of these pipelines, these modules, they contain nodes. So these Python functions, and this catalog contains the IOs. And then what we visualize is the entire pipeline, where the blue ones are these functions that we showed before, and the colored ones are the intermediate steps. This is just one way of visualizing it with Mermaid. Could be any way. I just want to show that it's relatively easy to get an overview, if you could actually read it, of your pipeline. And there is also a logical correspondence between how you structure your project. For example, this is a reg pipeline, where you say, what's this? So this retrieval module consists of two Python functions, retrieve and filter relevant. And then if you would run a certain file, so for example, run retrieval.py, then you will run this entire stage. So there's, this we like a lot. Probably you've seen these patterns, if you've worked with this, if you've done software engineering, right? So what we were interested in was mostly, what if we ask students from the ground up to work in this way? And so what we've seen is that once they learned it, it's very convenient, easy for them to modify the code. So one of the students, he just graduated, I think, 2 weeks ago. He found that he had data leakage, and if he would have done it in a notebook or in any other kind of way, then it would require much more edits. Well, here it was very simple to fix it. And sub-pipelines are also far more modular, so if I ask them to redo a graph or redo an analysis, I want to give feedback, then it's for me also very predictable how much time it has to cost them, right? Where if they build something from scratch, which is super complicated, it's very hard to understand, okay, is this a reasonable demand within these 6 or 9 months that they have to finish something or not? So that's quite nice. And they can also easily add, for example, another experiment or a hyperparameter search, those kind of things. The code is also much easier to understand. This is also in between them. So one of the students gave it to the other student because he had to continue on it. And this makes this global order, local chaos makes that from a high level it's easy to understand. And the visualization I've already showed. So these are things that are positive for these students. The negative things is that it's a very steep learning curve, and joining the bank, they need to onboard to the bank, they need to learn about the specific topics, so in this case some kind of entity matching algorithm, they need to learn about how to write a paper or a master thesis, and then you force them to use some kind of framework, so this adds on top. So even for people that already did functional programming, it's still a lot to learn. It's also rigid, and on purpose, the framework is opinionated using these functions. For example, the hyperparameter tuning can only be done in one way, because you have to loop in a certain way, and that's strictly DSL. Then a lack of ORDEC itself is that we have a lack of paved road, right? So we didn't apply this too much, only to a couple of our own use cases, so documentation incomplete, you know what it is. So for advanced patterns, we could have made something more. Intrinsically, it's very hard to make a distinction between an I/O and a node in some cases. For example, if you have a third-party library that will, after inserting something, will return part of that, or it will automatically create something, is it then saving and loading, or is it a function? If it does both, that has been sometimes hard. There's always only one right way to it, but this will be challenging. And then we come to the ugly, and the ugly, I would say, is the parts that are broken in the framework or limiting in the framework that I just proposed, or at least part of the design patterns, that not easy to fix. So the previous two were more reflection on the students. So for the control flow, we made certain assumptions. So currently, we don't allow people to do, for example, a for loop over these functions. For example, if you want to do hyperparameter search, you have to do it in a certain way. But that does mean that you have to support all different patterns that you can think of, so streams, fan-out, generate, repetition. I think it's similar to what you saw with these Q tiles, if you saw it this morning, to be able to express anything that's interesting. For example, also dynamically building such a DAG, if you say, oh yeah, if I'm on the cloud, I don't want to run a certain node that I want to run locally. We didn't make that yet, so it is an unintended limitation. Second, if you recall, I said also we pair the load and the save function, but in practice that doesn't turn out to be really something you can assume. For example, if you load an entire table but only append a partition, how do you do this parity? Do you make then different IOs? How does that work? Turns out that that's not something that we wanted really, and the other is that also sometimes you want to save something and not pass it on. Sometimes you want to save something and leave it there. So also the I/O should be part of this computation graph. It's just not the part that's most interesting always. So in general, we see this pattern coming back. We recommend it. I mean, it's proven in many cases. It's also in many frameworks like DBT or Cadro. Prefect also has some of it. It helps with reproducibility, quick and scalable experimentation. Take in mind that switching to a more functional-oriented development for your high-level pipelines requires this upskilling that pays off. The framework itself really depends on your project. So if you only do SQL, for instance, then by all means use DBT or something that's specialized for it. But if you use have a project that uses all kind of Python data formats that you need to mix, then ORDEC or Cadro could be a good choice. And for us as developers, we really want to go back to this drawing board to make this ORDEC framework even more lightweight and lift these ugly issues. And yeah, that's my talk. Thanks, everyone. I hope I was clear enough, but I'm not sure because it's, in hindsight, I wanted to add some more programming examples, so feel free to ask any clarifying or critical questions. You have one microphone.
Thanks. That was clear enough, at least on my side. So I have a question. So when it comes back to machine learnings, where you have a training and a testing stage, so basically you have a state. How do you handle basically the states within the pipeline in this case? So for instance, if I have standard scalars, I will have like a stage where I fit and learn statistics, which I should not do during the testing, okay? So it means that you have a function here are not enough because you want to have a class probably to keep the states of the fits to apply them on the testing. So here, seeing that I have the impression that you are pure function also. How do you manage that? Yeah, so in the class you add so fit and predict will only transform the data, and then fit will fit transform, and predict will only transform the data and then pass it. But you are able to do the transform because you already have the states of the different classes here.
course, you could do that in one go, but then that assumes that you don't give the state back at the end.
Okay, so it means that basically so you have a fit path and a test path.
Yes, so here we do the same. So we're doing, let's see, out of training, out of training you get the trained model, and then it's passed into inference, which I would say if you would do a fit, you get the fitted model with the scalar, and then this is the platform.
Okay, so you have to manage everything yourself in that case. Okay.
Probably you can condense this if you already know that the inner state is no longer used. If you do a fit platform.
Okay.
Yeah, thanks for the cool talk. I just want to kind of give some context on my background because this is kind of very, like a very common problem that we deal with as well. So I'm from the bioinformatics side where we deal a lot with pipelines, you know, where you create certain analysis, you create an output, you funnel that, and then you start building very big pipelines and processing hundreds of files like the same way. So I was also kind of curious to see, because I guess your domain is like more on the banking side, so that would be different domain, but I think similar problem. Have you considered like solutions from other domains, like for example in bioinformatics, where we have tools like Nextflow, SnakeMake, and if so, then how do these approaches compare?
There is design pattern that works universally. But, for example, if you do analysis of the gut bacteria, right, then you do this entire shotgun sequencing, and you go out into, then you do find some correlation analysis. This is all a Python data pipeline. I think within the Python ecosystem, the problem there often is that these tools are pretty high level, so you don't have the control to be able to use this. You have to have lower level control because everything you do in here, you need to take the third-party library, right? So in principle, it's compatible as long as you have the third-party tool do the steps that you would not manually do, or you have to abstract it entirely away. But then it gets pretty boring because then the inputs to all your steps will be the arguments to those third-party libraries, but then possible. I'm not sure if I answered your question or a different one.
Well, I mean, I guess there's like two different concerns. Like one concern is how do you define and execute the workflow, which is like a task in itself, and then the other is one like what is the behavior of each step and each module. So I think that is like can be a third party, can be a very simple function. A third party library could also be a combination of multiple things. So I think that's up to the user. But I think in terms of workflow management. So I also wanted to ask if you have, so if you need to rerun this workflow that you show like multiple times or it fails in between, this design pattern should be quite useful to be able to pick off where you left off, maybe fix a bug and so on. Is this something that you support, like to minimize the beginning to end computations?
On the other hand, a lot of frameworks already do this. So I mentioned Gero, DBT. So it's nowhere unique. But indeed, that is the big value of doing it this way, where you can decide, okay, I only care about this part of the pipeline that you're doing.
And maybe one final very small question, if I may. So with this workflow, if I understand correctly, at each step after each module, you have to save an artifact of your data. Does this then end up with your storage kind of exploding the more complex your workflow goes, or is there a way that you smartly handle the data?
I'm not sure if I understand.
So I guess the more complex the workflow goes, the more copies of your data you might need to save, or do you engineer that away?
Not necessarily. So that's up to the user to define, right? So where in each step where you take the test features, you can decide how you want to store it. Yeah, every time you try to append or you add a new thing with a timestamp, yeah, then it gets closed. But you could also choose to not version it in that way. Or use this caching approach where you say, okay, now I'm happy with the model and only do the last part. This is not very much. That's all.
Thank you.
Interesting talk. I have a question about pure functions because I have to teach like what's called functional Python. And the first thing I would say, pure functions are nice, but you cannot guarantee because you can overload the plus operator and add can do anything. Do you have any way to enforce or kind of encourage people to write pure functions?
That's a fun question. So actually in this talk that we did in session, it doesn't matter. So what we try to do is make a hash of a Python function, and then it also helps that if it doesn't have any side effects, because otherwise if the hash can be the same, but the code can try to read something internally, and then the hash shouldn't be the same. If you want to say, okay, I only want to run this function if it changes, then you want the hash that. No, this is super hard to do, especially. So there's some linting. So I did a couple of contributions to Growth, the Python linter,
okay.
and they do have some Mr. Popper, this package that they try to pull.
Yeah.
It's surprisingly hard to do statically.
Yeah, you can only look at if people do it accidentally, but if you do it intentionally and you try hard enough to meta programming, there's no way to prevent side effects in Python. Yeah.
How we use this in practice is that we use this catalog approach to say, okay, this is our real data, this is our mock data,
Okay.
and the output of the mock data after the transformation is also snapshotted. And if there's any change after running, the CI will fail. So that's, I think, the easiest way to test it. So in principle, like non-determinism, you can more or less catch, but no, we just try to do.
But if it manipulates some totally different data you don't have on your pipeline somewhere else, doing something with something totally different, like totally orthogonal to your thing, then you cannot prevent it from doing so. Yeah. Okay.
Anyone else?
Do you use, for example, request returns library, which what's the mechanism underneath for the keep it functional?
This warning package doesn't have any dependency.
Okay.
Because that's so I'm a member of the Kero Technical Steering Committee, and one of the problems that they have there is that it's a huge package, which is prohibitive if people want to schedule it in Airflow or any kind of orchestrator. So what we tried here is from the ground up to do it with zero dependency.
Oh, I see.
I'm not sure if that's the best choice, because some packages are really good. That's what we. Of course, if you want to save Poland Parquet, well, then Poland is a dependency. The core framework is the orchestration, partial running, and zero.
All right. Okay. Thanks.
Anyone else? Okay. So thank you very much for your talk. I think the next talk is taking what? 2 minutes? No. Okay. Okay. Nie wiem, który jest. Chyba jest otwarty, tak powinno być. Okej, to można by go wyłączyć, co?
Się wyłącza, Tego nie wyłączy, wiesz?
Nie, włączy.
This is. You want to present? Okay. Sure. I can also do it. So, welcome to the afternoon session. Thank you so much for coming. We are going to have a talk about towards Pythonic costume constraining in FreeCAD 2D drawing by Antika. Sorry if I pronounced the name wrong. Thank you so much and enjoy the talk. The floor is yours.
Yes. Question is, with this API, you would provide constraints from Python to the solver, but it would be in form of a Python expression or some code, right? So that means that the solver would effectively call into Python, and is the solver already implemented in Python, or is it actually like a C++ library or something like that?
Yeah. So the solver is in C++, yes. So yeah, I would imagine that it would have to connect in that sense. Although there is already an expression engine, which, I did not mention it here because it complicated things a little bit too much. But you can basically provide that kind of an expression, which will set properties. And you can go crazy in that. You can add trigonometric functions, you can add logarithms, and a whole bunch of those things. And I haven't explored yet about how it entirely connects. Does it go through Python? Is it possible to just take the string and just use the C++ part? But I would imagine that lambda that I've added in my pseudocode, it would be ideal if that is an expression for that engine itself. Yeah, ideally. Yeah. Although, yeah, of course, if you really want to make it happen, or if you just really want to prototype, we should be open to providing Python expressions themselves. Yeah.
Hello, and is the solver using implicit equation for solving? The constraints are represented by implicit equation, or there are rules for solving explicitly? Is a minimizer, or is actually? Is a minimizer on an error on the constraint? Okay.
Do you have some more questions? We don't have.
The online, we're recording. You can also then share your slides if you want on the Discord channel regarding to your room. If you want. If not, you can also just go to GitHub.
Okay, so thank you so much for the talk.